So, to rewind, the original model was called cross-lagged panel correlation, CLPC, literally done as correlations, and was proposed by David Kenny. This approach examined the relationships as correlations, not regressions, and it did not control for autoregression. Kenny proposed some side tests for stationarity and stability, but those didn't influence the correlation estimates. A subsequent modification in the early SEM era built in correction for autoregression. A revision to the CLPC was the CLPM, the cross-lagged panel model. As we just said, this built in autoregression. It indirectly looks at the chicken-egg problem by asking, is one path consistently more significant than the other? CLPM doesn't formally set quality constraints over time, in part because it doesn't make sense to compare the size of B weights unless measures are in the same metric. More on that in a minute. As you see here, what comes first is the autoregressions. So now each occasion represents the unique variance at a subsequent occasion, the residual change. After the autoregressions comes the crosslags. After the autoregression and the crosslag is the recognition that each value of x and y now have residual variance, variance left over after removing association with the previous occasion. After autoregression, crosslags, and specifying residuals, we still need to adjust for concurrent relationships. So we specify concurrent relationships between x and y at each occasion. So let's see this implemented in code. This slide reads in a lot of data sets following the super helpful URL mentioned on line 8. It goes into far more complicated models than we have time for here, so we're really just using the first data set on line 13. In this data set, as the figure implied, there are 5 occasions, 1, 2, 3, 4, and 5, and x and y are measured each time. And at each occasion, after the first, x and y are predicted by the previous x and y. x1 to x2 is the autoregression, x1 to y2 is the crosslag, and vice versa. And this repeats for occasions 3, 4, and 5, as you can see on lines 3 through 6. Line 9 estimates the x-y concurrent relationship at baseline. Lines 12 through 15 estimate the residual concurrent covariance between x and y at each subsequent occasion. And then we run the model and get the summary. The T here stands for true, which I usually write out in full. And the int.ov.free says freely estimate the measured variable intercepts, something that is often fixed to 0 by different Lavaan routines. This is the thing we're most interested in the output, but it's a lot. So over at the left, I wrote out what each line represents. And of course, our focus is on the red crosslags. And because we're not certain if these variables are in the same metric or what, over at the right, I focused on the standardized regression coefficients. And they're almost all significant, except for the crosslag of x5 on y5 near the bottom. But for each pair of crosslags over at the right, I highlight in blue which of the pair had a higher standardized value. And in every case, it was the path from x to y that was larger than the path from y to x. So it's tempting to say that x is a leading indicator. But there's a problem because we're not doing a significance test. We're not testing whether the path from x to y is significantly bigger than the path from y to x. But we'll come back to that idea in a little bit. And the rest of this output I put up, but it doesn't really address anything substantive. So this is more of a cue to ignore the covariances, intercepts, and variances, unless you have specific questions. Like here you also want to make sure that none of the variances go negative. But now let's step back and be critical about this for a minute. The good news about the CLPM is that it includes the autoregression. But it still has some other problems. Like all models, it's reductionistic in that it consists of only two variables. So like we talked about before, what if the relationship between x and y is spurious in a classic sense? An outside variable or more than one causes the relationship. And perhaps more important, the CLPM ignores the fact that, even putting spuriousness aside, there are two different reasons x and y might correlate it, and we haven't yet partitioned these two sources of variance. This is actually a familiar problem to you.